Bismillahirrahmanirrahim. Assalamu alaikum. So, yesterday we did closure from the ground up functions chapter. We completed this chapter and we learned about let bindings and global bindings using def and how to define functions and what is def and what are vars, etc. What are keywords, symbols, how does type work, etc. We did all that. And today we can either go closure from the ground up sequences and learn about these, or we can start this data types and immutability chapter in the Clojure workshop. I think I want to go this route, the Clojure workshop route, because for me, for example, in the Hello REPL chapter, they told us about a lot of things and I learned a lot in this just one single chapter, and I think this would be more informational and educational. So first we'll try to go over this book and then we'll finish this one, inshallah. So let's see how it goes. So first we'll learn about this data types and immutability chapter. Hopefully we'll finish this by the end of today's stream, and then we'll solve a couple of foreclosure problems and we'll see if there's enough time to start this next chapter as well, or if we should wait till next stream. Okay, so overview. At the end of this chapter, you will be able to work with commonly used data types in Clojure, discover the concept of immutability and its relevance in modern programs, and examine simple data types such as strings, numbers, and booleans, highlighting subtle differences in different environments like Clojure and ClojureScript. Basically, I guess they go through both Clojure and ClojureScript at the same time. Okay, in Clojure we work almost exclusively with immutable data types. They are safe to share, easy to fabricate, and improve the readability of our source code. Yeah, I knew about this, that here the data is, or the data types are immutable, unlike in other languages where data types are usually mutable. Immutable. An immutable thing is that cannot be changed or that will never change. So by immutable, if data is immutable, for example in C++ like const etc, if I declare something a const, it's immutable then. Or in Python, a string is immutable, I guess. So if we want to modify a string, it will return a new string instead of modifying the original string. It doesn't mean that a piece of information cannot change over time. It can, but we record those modifications as a series of new values instead of modifying the original value. Yeah, updating an immutable data structure provides a new value derived from the original value. However, the original value remains unchanged. And this is called, these are persistent data structures. So apparently there is some loss in performance, but it's not really that big of a deal most of the time, unless we require high performance computing. Okay, complete and continue. So what will we learn about today? Simple data types. Okay. Okay, Clojure is a hosted language that has three notable major implementations in Java, JavaScript, and .NET. Okay, I didn't know that Clojure is implemented in .NET as well. Clojure.net. So we can use the whole .NET ecosystem, I guess. But Clojure is Clojure. Okay, these are all immutable data types: strings, numbers, booleans, keywords, nil. Okay, we'll probably get a little more detail about this keywords data type. Okay. Strings. We work with strings, I guess, from the first chapter, first sentence, or first program that we've written, Clojure. So we've a little bit idea of how they work and what they are. Strings are sequences of characters representing text. Okay, we can't use single quotes for string. Yeah. I would consider it as a symbol and simply return it. There's escape character, we know about that. And they're immutable, so they won't change. Simply a new value derived from the old value would be returned. Okay, they're just simply a sequence, a collection of characters. So by calling first on a string, it would give us the first character. And if we find out the type of this thing, A, it's a java.lang.character. Okay, so in Clojure it's a data type character because Java supports character, but in Clojure script, which is based on JavaScript, so there's no character data type in JavaScript, and so its data type is also string. The namespace that the string is defined in is called Clojure.string, and there are a number of functions defined there as well, which we can take a look at. For example, directory Clojure.string, it's blank, capitalized, ends with. So these with those function names that end with a question mark, they return either true or false. Escape includes index of, join, last index of, lowercase, recode, replacement, replace first, reverse, split lines, starts with, trim new line, trim L probably for left, trim R probably for right, uppercase. We can quickly look at trim L or doc, because it's defined in a string namespace which isn't included by default, so we'll have to type in the whole name. Yeah, removes white space from the left side of the string. Okay, that was string. Now numbers. We knew about big int before, so if we want to use big int, we can simply append n to it and it would be treated as a big int. For example, here type of 13n is big int, and big integer can store larger numbers. It supports larger numbers than a long. And if a number is too large to store in a long, it would automatically store it in a big integer. That's a neat feature. Clojure also supports ratio representation as well, rational numbers, fractional numbers, or you would say. Yeah, its type is clojure.lang.ratio. Notice it's not java.lang, it's clojure.lang, so most probably it is supported by Clojure, not Java. I wonder if I type 4x4, it would store it as a long or a ratio. Yeah, it would evaluate it. It would evaluate to 1, and the type of 1 is long. Then there are double. Okay, so any operation involving floating point numbers will result in a float or a double. Okay, so if we try to divide it, for example, let's type of 1 by 3 would be ratio, but type of 1.0 divided by 3 would be a double. Okay, syntax error. I guess it doesn't work like that. 1 by 3.0. Yeah, let me try this. Type of 1 divided by 3, it is ratio, and type of 1.0 divided by 3, it is double. Yeah, look, in JavaScript there is no concept of long and integer and short, etc. Everything is just a number. Type of one is JavaScript. Object is number. In JavaScript it's number. So if it was Clojure based on the JVM, then it would be of type long, and it would be of type double, and it would be of type ratio. But in JavaScript, these are all just of types number. Okay, so math.py is defined in the user namespace, or where is it defined? Can we let's try resolve math.py. Okay, resolve just resolve symbol, but inner cost to class Clojure.learn.symbol. So this is a symbol. How about can we evaluate it? The evaluation would be, how about